Let's briefly distinguish between ionic and molecular compounds using our lab results. One student used a number of compounds, saw if they were going to melt at a high or a low melting point, and if they were dissolvable in water, and if when they dissolved in water they conducted electricity. The hypothesis this student made is that ionic compounds dissolve in water and conduct electricity. From her experience, she decided that that's what she wanted to say. Also, since they were ionic, thought that they'd be hard to melt, and that covalent or molecular compounds would not dissolve in water or therefore conduct electricity in water and would be easy to melt. Studying several compounds, the student discovered that sodium chloride, a white crystal, had a high melting point, did not melt when heated on a hot plate, not going to avoid being dissolved in water. It dissolved well in water and conducted electricity in water. The student studied paradichlorobenzene, which smells like mothballs, and discovered not only does it have a low melting point, but it just kind of evaporated very quickly, that it did not dissolve in water at all, and therefore did not conduct electricity in water. She then analyzed what she had seen in the lab and decided that since she knew that sodium loses electrons and chlorine picks them up, that sodium chloride is ionic, must break up into water into ions because it conducted electricity, and so did the other compounds like sodium chloride that she studied, and found that therefore the compounds that did not break up in water into ions, did not conduct electricity, would be best characterized as covalent or molecular, since they were not comprised of elements that gave away or take in electrons, but rather shared electrons. Discussing that, yes, the hypothesis about ionic substances is correct, and so is the hypothesis about covalently bonded substances. That was also correct. Looking at the periodic table, we see that sodium chloride is made up of elements on the far left and far right. If you study potassium iodide, you found out the same thing, made up of elements from the metals and the nonmetals. And calcium chloride as well is made up of elements from the metals and the nonmetals. If you studied copper sulfate, you saw that the copper sulfate was ionic, and again it was formed from a metal, and in this case sulfate, two nonmetals, because it's SO4 with a -2 charge. But going on to the covalent molecular compounds, we would discover that they're made paradichlorobenzene of carbon, hydrogen, and oxygen. Benzoic acid, again, carbon, hydrogen, and oxygen. Sucrose, once more, carbon, hydrogen, and oxygen. Therefore, we say, from the position on the periodic table, elements that form ionic compounds are metals combined with nonmetals, and covalent molecular compounds are made up of nonmetals that are close to each other on the periodic table on the far right.